Alrighty, good morning, everyone, and welcome to our Florida Nature Walk. My name is Margaret Davenport, and I am the Jill Abrahamson Memorial Environmental Education Intern here at Archbold. Today, we're joining Mr. Dustin as he explores the scrub, specifically a really cool burn site. It's super exciting. Remember, all participants are muted and your video cameras are off. Use the chat button to communicate with Mr. Dustin, other participants, and myself. And make sure when you're using it to choose the all panelists and attendees so everyone can see your comments. There's also a Q&A button to ask questions. It is in the center middle, or sorry, excuse me, center bottom of your screen. And Mr. Dustin and our guest will answer questions at the end of the field trip. Great, that's all I have to say. Dustin, can you hear me from the field?
I can hear you there, Miss Margaret. Good to see everybody. I think I'm kind of have bad lighting. There we go. Hi, good morning, buenos dias, everyone. Like Margaret said, I'm in a very special place today. And I really want you to contrast that's happening. We've got beautiful green plants, green scrub behind me here. But if I turn my camera just a little bit, look at this other world that's behind me now. All of a sudden, it looks like we've gone to another planet. We're on Mars or something like that. It's pretty amazing. So we're going to get into all that today and go exploring in there. We have a guest with us. This is Miss Chelsea Moore behind me. You can see her back there. Before we jump into all that, I had this awesome experience last week. I was hiking around, shooting some films of flowers and bugs and stuff, and I stumbled across a very cool animal. So I got a quick little 2-minute video clip of it. Margaret, if you could put that on, just shows you sometimes you just got to go out over and over again because you never know what you're going to find. Hey everyone, some days you just get lucky. I was out here walking around the Florida scrub and came across this Florida pine snake right here. I've never seen a Florida pine snake in the wild before. Most people haven't. They spend most of their time underground. So this really is a pretty wonderful find. I do see there's a Gopher Tortoise burrow ahead of me over there, and I wonder if this snake was going to travel across the path and go down into the tortoise burrow, which is where they spend a lot of their time. I'm going to switch my camera around here and see if we can get a closer look. I kneel down on the ground here, and my phone is on the selfie stick, so I can put it out ahead of me a little bit like this. I don't see it displaying any signs that it's too nervous about us here. You know, it's not rattling tail. Just kind of sitting there looking at us. I put the phone a little closer. Beautiful. I won't get any closer than this. I've got my arm extended and then the selfie stick extended out there. What a wonderful encounter. Look at this beautiful, beautiful snake. Now, do you notice that the nose on the pine snake is kind of a snubbed nose? And that's because it spends most of its time under the sand, so that helps it dig under the sand. The other thing that's interesting about them is the coloration. Near the head, it's kind of dark, a darker color, but as we get back towards the tail back there, it's more of a pine cone brown. You might also say, Dustin, are you sure that's not a rattlesnake? Yes, I'm sure it's not a rattlesnake. They do look a little bit like rattlesnakes, and they will rattle their tail, but they do not have rattles. And this is a non-venomous, harmless snake, though it is big enough that Thank you, Margaret. How amazing is that? You really do have to just keep visiting the same places over and over again, and you will see something different every time you're out there. There is so much we can learn by going out into nature. Now look at this amazingness all around me right here. So awesome. Get this up nice and high so you can see what's around me here. We are in an area that burned 5 days ago. That's it, just 5 days ago. So I'm always talking about fire on these virtual field trips. and saying, oh, this area burned 5 years ago or 10 years ago, but right here, 5 days ago. And when you look here, it might look a little scary, or maybe it even makes you feel bad, like you're worried about the forest burnt down. But this is very normal out here. It's very natural to have fire. In fact, almost all of Florida has plants and animals adapted to live with fire. I'm going to switch my camera around here though, so you can take all this in even better than you are right now. Take a look at this. Right here in front of me, what is this? This is a baby pine tree that has transformed. And all of this on the ground with me here, these are all saw palmetto roots. And right now, everything looks pretty dead. But if you came out here just a few weeks from now, you would see green, lots of bright green, beautiful new growth popping up everywhere, all over the place in here. This type of habitat, the Florida scrub, has all kinds of different ways that plants are adapted for living with fire. We're not going to go into all of them, but we will show a video, not just yet, but we'll show a video in a couple minutes. Let me switch my lens here. We'll show a video in a few minutes here showing like some of the adaptations of the plants. But let's just talk about fire for a little bit. Why is there so much fire in Florida and not in other places? Well, first off, there's more fire around the world than you probably realize. But Florida has a lot of it because of all the lightning strikes and because we have a dry season and a wet season. That's how our climate works here. It's a humid semi-tropical climate. And right now we're just finishing up the dry season where we've had almost no rain for about 6 months. And we're moving into half of the year of the wet season, which starts in just a few weeks from now. Though if you live around here, you know we have had some rain, we've had some storms lately, but it's still pretty dry. So if you do have those first storms, particularly in May, when those storms come in with all that lightning, you've got dry plants and lightning. And you need 3 things for fire. So you need fuel, that's the dry plants. Lightning provides the heat, and then you need oxygen, and we've got plenty of that out here too. So that's the fire triangle. And if you looked at how many lightning strikes hit different parts of North America, Florida would light up. We have the most lightning strikes per square mile here than anywhere else in all of North America. There's only 1 or 2 other places literally on the whole planet that get more lightning than we do here in Florida. It's pretty amazing. Today, we do a lot of prescribed fires. This site here actually is not a prescribed fire. This was one that we were not thinking was going to happen. This was a wildfire that happened last week. And it ended up burning about 230 acres here. But luckily, this is Archbold. So the second we saw smoke, we had a whole bunch of trucks coming out here. A lot of the staff here are trained to deal with fire, and we were able to manage it and make sure we could keep it where it wasn't going to get out of control. And like I showed you before, there's all that green behind me. One of the reasons we have these sand roads here is to help control fire, so we can keep it within certain lines and not going wherever it wants to go. All right, we are going to, I want to put the video on because I want you to see what the fires look like. And in the video, we also will see the regrowth. We're going to show just 2 minutes of this. It's like a 20-minute video, I think. Check out the regrowth that happens.
Most plants here agree that the best way to survive the burn is to go below ground. The tortoise knows that. So do all the insects, lizards, frogs, snakes, and mammals who burrow into the sand or use tortoise burrows to escape the fire. Scrub plants like oaks and palmettos store everything vital below ground in massive storage organs, roots, and rhizomes. Below ground, fire can't do much to you. Heat dies quickly on the surface of the ground, rapidly cooling in the dense sugar sand. Research at Archbold showed 80% of the palmetto is subterranean. Fire consumes the above-ground vegetation, but fire does not kill these plants. Within weeks after a fire, palmettos and oaks rise again out of the black. We call them resprouters. Resprouters use nutrients left by the fire to help produce new green shoots. In nature's big picture, this is a small setback. By burying temperature data loggers in the sand right before a fire, we can study the relationship between fire temperature and the survival and growth of the resprouters. We have found that oaks and palmettos are resilient to a range of fire frequencies and intensities. They can tolerate temperatures up to 1,000 degrees Celsius. That's
Thank you, Margaret. All right, so while the video is playing, I took a little hike out here. Chelsea is out here at a very cool spot, and I don't want to give too much away. I'll hand it over to her. But Chelsea, first, could you just introduce yourself a little bit, and then we'll see what you got here. Let's turn my camera around.
Hi, everybody. My name is Chelsea. Thank you, Mr. Dustin and Miss Margaret, for having me on today. I am the Gopher Tortoise and Data Science intern here at Archbold. So I'll be here all year studying Gopher Tortoises. And these animals are really cool, and they live in a habitat that has fire. Like Dustin said, a lot of the plants and animals here have adapted to live in habitats where fire happens frequently. And the Gopher Tortoises have a really unique way of dealing with fire. So you can see right here where we're standing, right behind me, you see this big mound of sand. And I don't know if you can see off in the distance, you might see a few other spots that look maybe like the sand is whiter or there's a little mound. A lot of those could also be Gopher Tortoise burrows. So this animal is a reptile, and it burrows under the ground. And these burrows can be really long, and we're gonna see how long this one is today. But before I show you the cool tool that I have here, I just wanted to give you a little bit more information about the burrow itself. So as the tortoise digs its burrow, this is the sand that is left behind out of the hole, and we call this the apron. Now this is the mouth of the burrow where it opens up. And we are really, really careful when we see Gopher Tortoise burrows, we're really careful not to step right above the mouth because that can cause the burrow to collapse. So maybe if you're ever out and you see a hole that kind of looks like this, you want to be really careful not to step above that mouth because it could collapse the whole burrow. Another interesting thing about the Gopher Tortoise burrow is that this apron right here is often where the females will lay their eggs. So in the next couple of months here, we want to also be really careful not to maybe step on the apron or kneel here. And I have to be aware of that too when I'm using the tools around the burrow. Now the burrow is a safe haven for a lot of different animals that live here when fire happens. And so we call the Gopher Tortoise an ecosystem engineer and a keystone species. And you may have heard that before if you've logged on to the Nature Walk with Mr. Dustin. They're considered an ecosystem engineer because they create habitat for a lot of other animals that live here. Insects, other reptiles like the pine snake that we were talking about earlier, little frogs that you might find in the scrub. And so that's also why it's considered a keystone species, because it's really important habitat. This burrow is really important habitat for a lot of other animals that live here.
All right, Chelsea, I want to just show them, show the burrow off a little bit here.
Yeah.
So
Okay, so the tool that I have here today is.
Well, hold on. Let me just show them so they can see this. So here's our burrow. And can you see this tool? She's going to talk about this tool in a second. You see how there's looks like something sticking out of here, almost like a water hose or something, and she's got a little backpack there. Okay.
So this tool is called a scope, burrow scope. And when we find a burrow, we might not always know if there's a gopher tortoise in it. So this tool is used to figure out if there's a tortoise there. And we're gonna see if there's one there today. So this long hose goes into the burrow, and at the very end, there's a little camera. And then it attaches to this screen. And we're gonna see if you guys can see what's at the end of this burrow. And then we're gonna see how long the burrow is.
Yeah, how long usually are these burrows?
So they can be 10 feet long, 20 feet long. There are papers that have found burrows to be 30 feet long. So these burrows are really, really, really long tunnels underground. All right, let's see.
So you can see live as you're doing it on the screen there?
Yeah, so right at the end of this hose is a little camera. And I can see down in the burrow. Get a look at this.
All right, let's see if we can get this to come up on the cell phone here. It might be kind of tough.
Let's see. So there might be a root there or something. Sometimes when we're scoping, we might find a snake or different insects that are down in the burrow. I don't know if you can see the sand and the root down there.
Yeah, definitely can see the sand, see some roots.
Let's see if we can find a tortoise. Now it's really difficult when we're done scoping this burrow. I'm going to pull out the scope to show you how long it is, but it's really difficult to maneuver this really long scope down in a tiny little hole here.
Yeah, I've tried it myself, and I can say it was much harder than I thought it was going to be.
Let's see if we can see a tortoise.
We're seeing lots of roots, lots of sand. Do you know anything about the tortoise that's in this one? Is this part of a project? Does it have a number or anything?
So the tortoises that are out here in the scrub, I'm not sure if this one has an ID or not, but we do a lot of the research here on gopher tortoises on Red Hill is the habitat we call it. And it's a part of the station where there are a ton of tortoises. Oh, there's something.
Looks a little fuzzy.
Wet. So we just got a heavy rain two nights ago, and so there might be some water down in the bottom of this.
I can't really see too. I think it looks pretty fuzzy.
Oh no. Well, maybe we'll have to scope another burrow to see what we can see down in there. See if I just spin the hose just a little bit, the end whips around. Can we see?
Oh, it definitely looks wet.
What's that?
Is that something there?
I don't know, I can't.
Yeah.
Maybe it'll get upset with us and come after us. So tortoises use these burrows for thermoregulation. That's a big word. But if you guys know anything about reptiles, you may have heard the phrase cold-blooded before. And there's another word for that, and it's called ectotherm.
I'm gonna put this back on you so they can watch you. And if we get one, then I'll show it again. So we can see how she does this. Now I noticed that your box says Disney on it. What's going on with that?
Yeah, so I am able to do research here because I was funded by the Disney Conservation Fund. So they've given us money to have researchers do conservation work with gopher tortoises.
Cool. Oh, can you pop your hat off so we can't see your face?
Yeah.
There you are.
Whew. It's getting hot under there too. Yeah, so tortoises use these burrows because they're cold-blooded, and you may have heard that before. And there's another fancy word called ectotherm. Now, what that means is that unlike humans, right? So when we're mammals and we're warm-blooded, What that means is that no matter what our environment is outside, our internal body temperature is always right around 98 degrees, right? If you have a fever, maybe sometimes you'll take a thermometer to get your temperature, and it's always right around 98. Now, tortoises, reptiles, and amphibians, their body temperature depends on their environment. Oh, I may have.
Oh my gosh, did you get one?
No, it's so hard. I don't think so. I think there might be one in here, but it might be too deep. Should I show how deep the burrow is?
Yeah, why don't you pull it out and show us? And I think we'll have enough time. We could try to scope a second one, and maybe we'll get lucky with the second one.
All right, so let's see how long this burrow is. You guys ready? About 1 meter, 2 meters, 3. So that's a pretty long burrow, and we may have not even been at the end of it since we didn't see a tortoise down in there. So these burrows can be really, really long.
Awesome. Thank you so much. I'm going to flip back to me, and while I'm talking to you, I'm going to put my macro lens back on here because I love using the macro lens. And I did come out and scope around here this morning, and I found something cool that I want to show you. I really want to show you. Just need to walk right over here. Now, you might remember that a couple of weeks ago, I did find a living a centipede and a millipede. Well, when I came out this morning, I found a dead millipede that looks like it died out here in the fire. And, most of the animals like the, deer and the gopher tortoise and the birds, they don't have to worry about the fire. They can fly away or run away or get down under the sand. But definitely a lot of insects die. And actually, the birds love that. It's a total feeding frenzy when you have fire. In fact, in Australia, there's a bird that actually starts fires. It'll take a piece of wood, a branch that's on fire, and pick it up and fly it to a new place and drop the branch to start fires so that it makes it easier to get to all of the grasshoppers or whatever insects they're eating over there. But here we go. I've got this kind of sad looking thing here, but let's take a look. Oh yeah. So poor little beastie here, but gosh, that does look pretty cool. So you can see this was a millipede, and out here in the scrub you don't have a lot of decomposers because it's not like areas where you dig around and there's just tons of worms everywhere because we've got all this sand here. And so the millipedes are a really important decomposer in the area. Let's see, since I'm already got the macro lens on, I want to just take a look at what does the burnt surface of some of these plants look like? Let's see here. They look like, ooh, I just broke it. They look like charcoal. That's where charcoal comes from, burnt plants. There we go. Oh, look at that. It's like silver color. This is the outer part of a saw palmetto. And like I said before, it looks kind of like it's dead, but it is not dead. You saw from the video how fast these spring back up to life. This outer bark here is doing a great job of keeping this alive. Normally, when you walk around in the scrub, it's pretty tough to do if you're not on a trail, because there's so many palmettos. They tear. You would never want to have shorts on. They tear you all up. You got to get a new pair of pants every year, some new boots, because saw palmettos just rip everything up. But after a fire, it's amazing to walk out here and actually see all these palmettos. I'm going to put on another video. This one's like 5 minutes or so about palmettos, and it'll give us a chance. Chelsea and I'm going to run back to her ATV that's back. I don't know if you can see it. That's back there, and see if we can get to another burrow while the video is playing. And we'll try to scope one more, and maybe we'll get lucky. Okay, so Margaret, let's get that next video up. With Lexi Siegel, a research assistant in the Plant Ecology Research Program, because I am curious about saw palmettos. Lexi, can you show me a saw palmetto?
Right here.
So see that it kind of looks like a palm tree that never learned to grow to the sky. So they are growing along the ground. And the reason Lexi has brought her measuring tape with her is because we can actually learn how old that saw palmetto is by measuring it. We're gonna give it a try today.
So the first thing we're going to do is we're going to take the beginning of the measuring tape and put it down at the front end of the palmetto where the leaves are. Then we're going to stretch it all the way back until we can't see the trunk over the sand anymore. Then you can pin the beginning in place, and now we can see how long the palmetto trunk is. So this trunk here is about 90 centimeters long. After we get our total length of the trunk that's above ground, we divide it by 1.2, which is the growth rate for palmettos every year. So in this case, we take 90 centimeters above ground, 90 divided by 1.2. So the part of the palmetto that is above the ground that we can see is 75 years old. We're going to show where this palmetto was in its growth during a couple important dates, like when the movie Frozen came out. Frozen came out in 2013, and it's 2021 right now. So that's 8 years ago. So what we're going to do is we're going to take 8 and multiply it by 1.2. And we're going to get 9.6, which is how many centimeters back we need to go to see where this palmetto was. And that's about right here. So this palmetto was right here when the movie Frozen came out. I calculated this earlier, and on my birthday, which is 1996, 30 centimeters back, the palmetto was right here. And on the first Earth Day in 1970, 51 years ago, the palmetto was right here.
Where did this magic number of 1.2 centimeters come from? Well, it's not magic, it's science. Dr. Warren Abrahamson and his colleagues have been measuring hundreds of saw palmettos here at Archbold for decades. Around 40 years they've been doing these studies. And they found that at Archbold, in our Florida scrub and scrubby flatwoods where it's really bright and shiny, the saw palmettos grow about 1.2 centimeters on average. The saw palmetto that Lexi was measuring, we could see about 75 years of growth there. But if we'd start digging back into the sand, we could see that it was even older and continued to go back. If you actually dig up a saw palmetto, this is what it looks like. Almost like a alien crustacean or something like that. Here are the roots coming down from the stem here. This one doesn't have the protective bark on the outside. This is where the palm would be at the end. Here's the really cool thing though. Yes, they grow from seeds, but sometimes you can find saw palmettos where near the front tip, you can see that it branches. Saw palmettos branch, and then as that branch grows off further, it actually will become its own plant. How do you tell how old they are? Because after they start growing, eventually they lose their connections. You couldn't dig them all up and find the connections underground. Well, Abe and his colleagues, they did an experiment where they looked at all the saw palmettos in a 20 by 20 meter area, and they took a genetic sample from each of them. They could see by looking at the DNA if the saw palmetto here is the same one as the one that was over, 20 feet over that way. And then because they knew the growth rate, they could estimate how old that clonal group was. The average age was 5,000 years old. The oldest was 8,000 years old. And imagine if instead of 20 by 20 meters, if it was 40 by 40 meters, maybe the oldest would have been 10,000 years old. We know that these have been here for a long time and they live for a long time. We have a lake at Archbold called Lake Annie. It's pretty deep, about 70 feet deep, and we've actually taken cores from the bottom, scooped up the muck at the bottom, and we have found saw palmetto pollen that is 37,000 years old down at the bottom of our lake. Pretty amazing. So this species, not only does it live for a very long time, but it has been here at Archbold for a long time.
Thanks so much for joining us. Now you try this at home and see how old your palmettos are in your neighborhood.
Wow, the timing, I can't believe how good the timing was. I was a little nervous. It's not really something that you practice. It's just like, okay, there's another one 5 minutes that way. We're hopping in the vehicle. We're gonna go down there. I left the camera on. I was hoping, I don't know if you could see me because the video is playing. You could, so if you saw, type in the chat. Did you see us in the ATV when we were coming down here? It was pretty cool. So we've got another burrow. Chelsea's right there. She's trying to scope it out. We'll see if she can find anything. But I've got palmettos all around me again here. Though it's a little bit more open here. That other section was almost all palmettos. But what I'm seeing now are these other blackened plants here. And these are different kinds. Most of these are different kinds of oak trees. So we have our different scrub oaks. And I always say to people, you know, how do you know if you're in scrub? Well, you're in Florida, you're on white sand, and you've got scrub oaks around you. So yes, though our sand doesn't look too white right now because it has all of this ash everywhere. That ash is natural fertilizer. When you have a fire like that, yes, it's killing the above ground growth of these plants, but it also is putting nutrients back into the soil and stimulating new growth. All right, let's see. How are you doing, Chelsea?
I'm doing good. Haven't seen anyone yet.
Nothing yet. Here we can get a bit better view of her as she's working there. One of the things that I like about the scrub is that the more that, for myself, the more I learn about it, the more interesting it becomes. The first time I walked around and saw palmettos, I didn't know what the heck they were. It's like, it feels like we're in a tropical area with palm trees, but all of them got knocked over. Like, what is going on here? And now when I look out there, I see them as these ancient beings, thousands and thousands of years old, that have been here for so long that I like to imagine some of them might be even 10,000 years old when they first grew from a seed. Maybe there was a buffalo that came by, or a saber-toothed tiger, or a woolly mammoth. Maybe some of these are that old that when their seed first germinated, there was a woolly mammoth or a saber-toothed tiger walking past them. It just kind of blows your mind, right? Totally blows my mind. I also think that fire and burrows are a good way to think about trying to understand what an ecosystem is. I'm always dropping this word, ecosystem, because that's what Archbold studies. A habitat is a home for a plant or animal, a home for a species. But an ecosystem is something much more complex than that. The term ecosystem is referring to all the connections, that whole web of life. It's all of the living things in an area, but also the non-living things. You can't really talk about gopher tortoises without talking about sand. And you can't talk about any of these plants without talking about fire. And earlier I was talking about the climate here and the weather we just had. All of that is part of an ecosystem. So sometimes people wonder, like, Archbold's been here for so long. We've been here for something like 80 years. Didn't we figure it all out? Isn't there more to learn? Think about how complex that is. All of those different little parts of the ecosystem it's what makes it so much fun. And the longer you have a research station, the more questions you have. Not less. The more questions you have. Okay. All right. Anyway, so let's check back in with Chelsea once more.
Still no luck.
Okay. No luck. Let's see what our time is. Well, we've run out of time, so we need to go to our questions. Are you packing it up, or are you going to keep looking there?
I was going to keep looking at
Dustin,
you ran out of scope?
Yeah.
Wow.
Oh, wow. I have a few questions that you could answer maybe while Chelsea's still looking around.
Cool. That
The
sounds good.
first one is, can you talk about why we put out wildfires when normally fire is good for the landscape and we ourselves do controlled burns?
Yeah, well, I think the answer is kind of in the name of wildfire. I mean, fire is, the plants don't care if it's a wildfire or if it's a prescribed fire, right? For them, it's all the same. But for us, we don't want our houses burned down. And we also try to be strategic about it because we are studying rare species out here. So for example, if there's a baby scrub jay nest, we're not going to pick that spot this time of the year to do a fire. We'd wait till another time when they were not nesting. So that's a good example of, yes, we want to get these fires out here. The plants don't care about it, but we have our own management goals. Also, with a prescribed fire, it's all planned out ahead of time. You only do it when the weather is cooperating, when the wind is predictable and a certain speed. There's all these factors, so you don't just go out any day of the week and just burn an area. It's very carefully planned. If you have a wildfire, you don't know what's the wind doing that day. If it's a windy day, that is a lot harder of a fire to control. That can take that, carry the fire pretty far. What if the wind has been changing directions? That's pretty hard to deal with. If it changes direction, that fire is going in a new direction. When we're doing a prescribed fire, we use the wind to our advantage. If we know that the wind is blowing one direction, we can start our fire at the end of that spot so that it actually has to move against the wind. And if you've ever been on a canoe or anything and tried to paddle upstream, you go a lot slower. So if you light your fire going upwind or going into the wind, it's going to be a more controllable fire. I mean, fire is a huge, awesome topic, and I am not an expert on fire. We've had our fire expert, Kevin Main, on here before, but luckily I have been able to do some training with him and help out on some fires. All right, next question.
So we have a ton of questions for Chelsea about the Burrows, but I'll let her maybe try to figure out if there's a tortoise down there and hopefully ask a question that you might be able to answer, Dustin, which is, what happens if an animal comes into the burrow to escape a fire, but a tortoise is already there?
It just depends on how far down the tortoise is. I've seen videos of tortoises can turn sideways and it plugs up the burrow. They do have, researchers have counted something like 350, 360 different species that use tortoise burrows. Most of them are going to be bugs. But snakes go in there, birds sometimes, all kinds of things will go in there. And some even live in there. Like there's a mouse that makes its own burrow inside the gopher tortoise burrow. So sometimes the tortoise will just turn sideways and plug up right where it is so that nothing gets past it. But if you've got a 20-foot burrow and the tortoise is all the way at the end of it, the far end of it, that's a lot of space for a snake or something else to go and hang out in there. Okay, well, it looks like we're giving up on this one. All right.
That's just sometimes how it works. You check a lot of burrows, and sometimes they're there, and sometimes they're not.
I'll switch my lens around here. Take off my macro lens so you can see Chelsea better. And she can answer some more questions.
Awesome. So a lot of people are really surprised by how deep these burrows go. And they're wondering, does it snake around at the same depth, or does it typically change in depth and get deeper? Is it parallel to the surface? Lots and lots of questions about that.
Those are really good questions. So they do change a little bit in depth, but usually it's pretty close to the surface. So they'll go down a feet. Gradually, the tunnel will go down. But usually the ones that I've scoped haven't been too deep. They're just subsurface, right below the surface. But they do turn. Sometimes you'll be scoping a burrow and you get to a wall and you think that it doesn't go any further, and then you just keep turning the scope, and sometimes it'll, cut around that corner. So they will turn down in there.
And there's another question that is, what is the coolest or most unexpected thing you found in a gopher tortoise burrow?
Ooh, that's a really good question. So I don't know if it's the coolest that I've seen. I've seen a lot of cool things in the burrows so far. There's a species of frog called the gopher frog that specifically hangs out in the burrows of gopher tortoises. So those are awesome to find. The pine snake, I've seen a pine snake in one of the burrow mouths. The snake that Mr. Dustin saw last week when he was out, and that is also really, really cool. But I've also seen little crickets. So I've seen crickets down in there when I'm scoping, and they're hopping around. Sometimes they're really big crickets with really super long antenna. Yeah, so I've seen all sorts of stuff down there.
Awesome. And do the tunnels have any back doors or multiple entrances to them?
That's another really good question. No, usually when we're scoping, we just keep scoping until the end of the burrow. So there's one entrance in and out. And a lot of the times that's how researchers can study how many gopher tortoises there are in an area by studying how many burrows there are. Since there's only one entrance, you know that's one burrow, and it's a possibility of one tortoise being there. Sometimes, occasionally, they'll share burrows, but that's relatively rare.
Do you know what would happen if maybe like the mouth of a burrow were to collapse?
Yeah, that's a really good question too. So we try our best not to let that happen because of us. But a lot of the times the mouths do collapse on their own, depending on where the tortoise is burrowing. So if they're burrowing where there are a lot of roots and a lot of vegetation, the plants on the top, then usually the mouth is a little bit stronger. But sometimes they'll burrow just in open sand, and those collapse a lot easier. Usually the gopher tortoise can just tunnel its way back out when that happens.
And are turtles nesting in these burrows, or is this just where they're hiding out?
So I mentioned before this big mound of sand that's outside of the mouth. A lot of the times the females will nest right in that apron, right in that mound. So they're not nesting in the burrow. Their burrow is just used to help them regulate their body temperature.
And Karen just asked, at what age do tortoises start making their own burrows? And I think this is also a great lead in to ask about the juvenile research that you've recently started, I believe.
I'm just moving to get better light here on Chelsea.
Thanks, Karen. That is a really good question. So almost immediately, those little hatchling tortoises are making their own burrows. A lot of the times they'll use holes that are already started. So if they find a mouse hole, they'll dig away at that. But that leads into the juvenile study. And when we find a burrow mouth, the width of that mouth can also tell us the size of that tortoise and then often the age or a relative age. So when we find little burrows that are this big, it can be difficult to determine whether it's a mouse or a tortoise. But if you start noticing the shape of the burrow, it's almost like a half moon shape. But the tiny little hatchlings start burrowing. So the mouth of the burrow can be about that big. And then Miss Margaret mentioned the juvenile study that we're starting this year. So the Disney Conservation Fund funded me to do research starting up a juvenile tracking study. So we were going around and using our little scope to scope the tiny little burrows and capture juveniles and hatchling tortoises to put little transmitters on them. So it's really important to study the movements and habitat use of animals so that you can conserve the habitat that they're using. But it's also important to make sure that you're getting the movements and habitat use of every age class. Because if there are just adult tortoises around, they can live up to 40 years, but that doesn't necessarily mean that they're successfully reproducing unless you're finding these little tortoises.
I think that is really cool and really cute. I love walking around here and seeing very small, tiny tortoise holes. A question that also I think is an interesting lead into talking about predators is the Riley family noted you would think that the tortoises would have a way to escape predators. And I know there's quite a big difference between predators for mature adults and for juveniles, if you want to talk about that.
Yeah, so if anyone has ever seen a gopher tortoise, I'm sorry that we couldn't see one today, but they can get really, really big. So the adults can be really, really big, and they don't have many predators. Not many things are going to go after them because it's just too much work for too little, reward. But if you've ever seen a hatchling, they are tiny. They fit in the palm of your hand. So if you held your hand up, they're smaller than the palm of your hand. They're very, very tiny, and anything will eat them. So you have a lot of bird predators that will eat them, other snakes, mammals, so all sorts of stuff. Um, and I don't know, it also makes a difference where they're making their burrows, right? So a little juvenile tortoise has to worry a lot more about predation. So maybe they're using their burrows at different times of the day. Maybe they're making their burrows in different places. So a lot of the adult and juvenile behavior is going to change because of that.
Alrighty, I think we have one last question for you today, which is, do you know the size of our gopher tortoise population here at Archbold?
So I don't know an exact number, but I will tell you that we study, I think I mentioned before, we study the tortoises that are out on Red Hill, so a different portion of the Archbold property. And today, so as of now, I track 36 females, adult females. So it's a pretty large population. But again, that will also change with the habitat. So you might find more tortoises in an open habitat, maybe just after fire. We've talked about gopher tortoises being adapted to fire. They like having open canopy so that the sunlight can get down to them. They like a lot of grasses. So it'll depend on what kind of habitat, how many tortoises are there. So I don't know an exact number here at Archbold, but we see gopher tortoises a lot here.
On Red Hill is only probably a couple hundred acres, right?
Yeah, so a couple hundred acres.
Archbold's 10,000, almost 10,000 acres.
Yeah, so we have quite a few gopher tortoises here, but we also manage for them, right? So we have land management that makes sure that we're providing the habitat that they need. And that's what the conservation is all about, right? Finding out what habitat they need, and then how we can inform land managers across the state and then across the whole range of gopher tortoises, so that there is habitat for them.
Oh, one more question. Well, since we have a little bit extra time, do the tortoises come out mostly at night or in the day, and how much time do they usually spend in their burrows?
That's a good question too. So a lot of studies have shown that gopher tortoises come out at the hottest time of the day. So they'll come out afternoon. And I don't know the average time that they spend out of their burrow, but they spend a lot of time in their burrow. So maybe if I had to estimate, maybe like an hour or two a day they would be out. And that's also weather dependent. So they're not really coming out when it's rainy. During the winter, they're a lot less active. So they'll only come out on really warm days during the winter. So it's dependent on season, but they spend a lot of time in their burrow, and they sleep in their burrow at night.
Awesome. So that I think is all of our questions for now. If we happen to miss one, we will answer it in our post email that we always send out. Thank you so much, Chelsea, for taking this time out this morning. This has been super awesome. Even if we didn't get a chance to see a tortoise, just seeing how you do all the scoping is really, really cool. I don't have anything else to add. Dustin, do you?
Just a couple short things here. Thank you again, Chelsea. And we've only have, I think it's 2 more weeks of this before our season ends, because we're getting ready for our summer programs. Registration is live now. If you go to the Archbold website, if you have children 7 to 12 years old, sign them up for our summer program. We're not calling it a camp this year because it's virtual or mostly virtual. They're month-long summer ecology clubs. And we'll be doing the same type of stuff like this, but it'll be exclusive for those children that are part of that program. We'll have other things going on as well, but you'll get to meet a lot of the researchers, a lot of the interns like Chelsea, and we'll do more field trips and all this cool fun stuff. So that's it for me. Hasta pronto, amigos. See you soon, my friends. Bye-bye.
Bye, everybody. Thanks y'all for coming, and see you next week.